Dear students, today we will verify circular time shift property of DFT with the help of example. Verify circular time shift property of DFT for x of n equal to 1, 0, minus 1, 0 and for m equal to 2. Given x of n is equal to 1, 0, minus 1, 0, we have calculated the DFT of this sequence previously, and the DFT of this sequence is x of k equal to 0, 2, 0, 2. If we circularly shift x of n by 2 samples, that is x of n minus m mod n, which is equal to x of n minus 2 mod 4, that is equal to minus 1, 0, 1, 0, we get. DFT of x of n minus 2 mod 4 is equal to DFT transformation matrix 1, 1, 1, 1, 1 minus j, minus 1 j, 1 minus 1, 1 minus 1, 1 j, minus 1 minus j into x of n minus 2 mod 4. Simplifying, we get one into minus 1 minus 1, 1 into 0, 0, 1 into 1, 1, 1 into 0, 0, 1 into minus 1, minus 1, minus j into 0 0, minus 1 into 1 minus 1, j into 0 0, 1 into minus 1 minus 1 minus 1 into 0 0, 1 into 1 1, minus 1 into 0 0, 1 into minus 1 minus 1, j into 0 0, minus 1 into 1 minus 1, minus j into 0 0. We have to add all these. Minus 1 plus 1, we get 0. Minus 1 minus 1, we get minus 2. Minus 1 plus 1, again 0. Minus 1 plus minus 1, minus 2. Now we will calculate e raised to minus j 2 pi km upon n into x of k. That is for k equal to 0, e raised to minus j 2 pi km upon n will be equal to 1. 1 into x of 0. X of 0 is 0. For k equal to 1, m equal to 2. 2 into 2, it will become 4. 4 by 4 will be equal to 1. E raised to minus j pi means cos of pi. Cos of pi is minus 1. Minus 1 into 2. For k equal to 2, m equal to 2, 2 4 ja 8, 8 by 4, 2 pi, e raised to minus j 2 pi will be equal to cos of 0 or cos of 360, which is equal to 1. 1 into x of 2. X of 2 is 0. Next, for k equal to 3, m equal to 2, 2 2 is 4, 4 and 4 will cancel, k will be equal to 3. 3 pi, 3 pi is equal to 540 degree, and cos of 540 degree is equal to minus 1. So minus 1 into x of 3. X of 3 is 2. So we get 0 minus 2, 0 minus 2. If we call this as 1 and this as equation 2, from equation 1 and 2, DFT of x of n minus 2 mod n, where n is equal to 4, is equal to e raised to minus j 2 pi k into m, where m is equal to again 2 by 4 into x of k, that is 0 minus 2 0 minus 2. Hence verified. Hence verified. Next we will take time reversal property of DFT. It is property number 4. The time reversal property of DFT says that reversing the endpoint sequence in time is equivalent to reversing the DFT sequence, that is if DFT of x of n is equal to x of k, then DFT of x of n minus n is equal to x of n minus k. Proof. By definition, DFT of x of n, that is x of k is equal to summation n equal to 0 to n minus 1 of x of n into e raised to minus j 2 pi kn upon capital N. By this we can write dft of x of capital N minus n as summation from n equal to 0 to capital N minus 1 x of capital N minus n, because in place of x of n we are having x of n minus n here. So here also in place of x of n we have to put x of n minus n into e raised to minus j 2 pi kn upon capital N. Let m is equal to some new variable capital N minus n. Then small n will be equal to capital N minus small m. We get. Now we will put in place of n capital N minus m, and in place of capital N minus n we will put m. That is equal to summation, because I am going to place here capital N minus small n equal to small m. Here also I will have to replace small n by m. M equal to 0 to capital N minus 1 that is x of m into e raised to minus j 2 pi k e raised to minus j 2 pi k. In place of n we will put capital N minus m, and here we will take by capital N. I will expand this exponent part. M equal to 0 to n minus 1 into x of m into e raised to minus j 2 pi kn upon n into e raised to j 2 pi km upon n. Now n and n will get cancelled. E raised to minus j 2 pi k into e raised to minus j 2 pi km upon n will be having as exponent part since integer multiple of 2 pi is 360 degree, the value of e raised to minus j2 pi k will be always equal to 1. Therefore, I can replace this k by m now, because m is also some integer. For any integer, this first exponent will be always equal to 1. So, m equal to 0 to n minus 1 x of m into e raised to minus j2 pi m we have cancelled n, so we will not write n here, into e raised to j2 pi km upon n as it is. In the next step, what we will do is in this exponent e raised to minus j2 pi m will multiply by n and divide by n, which is again equal to 1, into e raised to plus j2 pi km upon capital N. That is equal to summation m equal to 0 to n minus 1 x of m into e raised to minus j 2 pi m into the bracket n minus k upon n we can write by using laws of exponent, by using law of exponent here. Now look at this expression and compare it with the definition of DFT of x of n. By definition of DFT of x of n, will be having e raised to minus j2 pi n k upon capital N, but here in place of k we are having n minus k. Therefore, in place of x of k we will have to write capital X of n minus k. That is DFT of x of n minus n is equal to summation m equal to 0 to capital N minus 1 x of m into e raised to minus j2 pi km x of m into e raised to minus j2 pi m of n minus k by n may be written as x of n minus k. Hence proved. Hence proved. Now we will verify the time reversal property of DFT. For that we will consider an example of x of n, for which we have already calculated DFT, that is x of n is equal to 1 by 3 comma 1 by 3 comma 1 by 3 comma 0. For given x of n, verify time reversal property of DFT. X of n is equal to 1 by 3 comma 1 by 3 comma 1 by 3 comma 0. Reversing x of n in time, that is x of capital N minus n is equal to, here we have to keep the zeroth sample as it is, and we have to reverse the order of samples starting from small n equal to 1 to capital N minus 1, that is in this case 3. So 0, 1 by 3, comma 1 by 3. Now we will find DFT of this x of capital N minus n. DFT of x of n minus n. This is equal to multiplication of total factor matrix with x of capital N minus n, that is 1 by 3, 0, 1 by 3, 1 by 3. Here 1, 1, 1, 1, 1, 1, 1, minus j minus 1 plus j, minus 1 plus 1 minus 1 plus j minus 1 minus j. Multiplying we get 1 into 1 by 3, 1 by 3 plus 0, because 1 into 0 is 0, plus 1 by 3 plus 1 by 3. Then 1 minus j into 0, 0, minus 1 into 1 by 3, minus 1 by 3, j into 1 by 3, that is j by 3. Similarly, multiplying, we get the remaining DFT coefficients here. So we are having DFT coefficients here now. Adding, we get 3 j by 3, 1 by 3, and then minus j by 3. Now let us call this as equation 1. DFT of x of n we have already computed, and that DFT is equal to 1 minus j by 3, 1 by 3, and j by 3. For this you can refer to your previous pages. And this is what for us now? This is x of k. Now we will compute x of n minus k. That is, we will reverse the sequence in frequency domain. X of n minus k. One plus j by 3, 1 by 3 minus j by 3. Here reversing process is same as reversing x of n. From equation 1 and 2, get DFT of x of n minus n equal to x of n minus k, that is equal to 1 j by 3, 1 by 3 minus j by 3. Hence, verified. Now we will take fifth property, that is conjugation property of DFT. Let x of n be a complex n point discrete sequence and x conjugate of n b its conjugate sequence. Now if DFT of x of n is equal to x of k then DFT of x conjugate of n is equal to x conjugate of n minus k. Proof. By definition, DFT of x of n is equal to summation n equal to 0 to n minus 1 of x of n into e raised to minus j2 pi kn upon capital N. Now DFT of complex conjugate of x of n is equal to summation n equal to 0 to n minus 1 complex conjugate of x of n into e raised to minus j2 pi kn upon capital N. That is equal to now we can write this DFT expression as summation n equal to 0 to n minus 1 of x of n into e raised to j2 pi kn upon capital N complex conjugate. It is also by using law of exponent. N equal to 0 to n minus 1 summation of x of n into e raised to j2 pi kn upon capital N into, if I multiply this product by 1, there will be no change in its value. And for us, 1 in the form of exponent is e raised to minus j2 pi n whole raised to complex conjugate. So n equal to 0 to n minus 1 x of n into e raised to j2 pi kn upon n into e raised to minus j2 pi. I can multiply this power here by capital N and divide by capital N. That will not make any change in the value of this e raised to minus j2 pi n, because capital N by n will be once again equal to 1. Summation n equal to 0 to capital N minus 1 x of n into e raised to minus j2 pi into the bracket n minus k upon n into n. Complex conjugate as it is. Now if we only look into this bracket, it is nothing but x of n minus k. So we'll write it as, x of n minus k and we'll keep complex conjugate symbol as it is. Now to verify this property, we'll take one example. For x of n equal to one j 0 minus 2j 2 plus 3j verify the property of complex conjugation of DFT. Complex conjugate of x of n that is x complex conjugate of n equal to complex conjugate of each sample, that is minus 1 by j, comma 0, comma plus 2j, comma 2 minus 3j. DFT of x complex conjugate of n is equal to total factor matrix into x complex conjugate of n, that is minus 1j, 0, 2j, 2 minus j3 or 3j, 1, 1, 1, 1, 1, 1, 1, minus j, minus 1 plus j, minus 1 plus 1 minus 1 plus j minus 1 minus j. Once again you multiply these two matrices and write the results. I hope you have got these results. Call this as equation 1. Now we will compute DFT of x of n. That is x of k, which is total factor into x of n. One j, 0, minus 2j, 2 plus j3 or 3j. You multiply once again these two matrices and see what do you get. Yes, after multiplication your result should be 2 plus 2j minus 3 plus 5j minus 2 minus 4j 3 plus 1j. Now we will reverse this x of k, that is we will write for x of n minus k. X of n minus k equal to 2 plus 2j minus 3 plus 5j minus 2 minus 4j 3 plus 1j. X of n minus k equal to x of n minus k is equal to 2 plus 2j 3 plus 1j minus 2 minus 4j minus 3 plus 5j. Now taking complex conjugate of x of n minus k, we get 2 minus 2j 3 minus 1j minus 2 plus 4j minus 3 minus 5j. Now let us call this as equation 2. From equation 1 and 2 we find that DFT of x complex conjugate of n is equal to x of n minus k complex conjugate, that is equal to 2 minus 2j 3 minus 1j minus 2 plus 4j minus 3 minus 5j. Hence verified. I will stop here. In next class we will take remaining properties of DFT.